Students, in our previous video, we were discussing definition of data structures, different types of data structures like primitive data structures, non-primitive data structures. Under non-primitive data structures, then we were discussing about arrays, types of arrays, right? Types of arrays, all these things we were discussing, and single dimension or one dimensional arrays we were discussing, and we saw like how to represent arrays and also basic operations which are performed on one dimensional array: traversing, searching, sorting, insertion, deletion, merging. Okay, so I have also told you to like remember the first letters and then you can just write. So they may ask like explain 5 basic operations performed on arrays for 5 marks. It has been asked in your like the textbook is there, right? In your textbook some of the questions are given from model paper, so in that they have asked. Okay, let's change the color. Okay, yeah, now we will go one by one. Traversing. Okay, traversing a linear array. Traversing is a process of visiting each subscript at least once from the beginning to the last element. For example, to find maximum element of the array, we need to access each element of the array. So ಟ್ರಾವೆರ್ಸಿಂಗ್ ಅಂದ್ರೆ ಏನು ಅಂದ್ರೆ ಯು ವಿಲ್ ಬಿ ಟ್ರಾವೆಲಿಂಗ್ ಅಲಾಂಗ್ ದ ಅರೆ ಇರುತ್ತಲ್ಲ, ಸೊ ಅರೆ ಟ್ರಾವೆಲ್ ಮಾಡ್ತೀರಾ, ಯು ವಿಲ್ ಬಿ ವಿಸಿಟಿಂಗ್ ದ ಅರೆ ಎಲಿಮೆಂಟ್ಸ್. ಒಂದು ಸಲನಾದ್ರೂ ಎಲಿಮೆಂಟ್ನ ವಿಸಿಟ್ ಮಾಡಬೇಕು, ಅದು ಟ್ರಾವೆರ್ಸಿಂಗ್ ಅಂದ್ರೆ ಟ್ರಾವೆಲ್ ಅಂತ ಅನ್ಕೊಳ್ರಿ. ಅಂದ್ರೆ ಅದರಲ್ಲಿರೋ ಈಚ್ ಅಂಡ್ ಎವ್ರಿ ಎಲಿಮೆಂಟ್ನ ವಿಸಿಟ್ ಮಾಡೋದು. ಸೊ ಇದಕ್ಕೆ ಒಂದು ಅಲ್ಗಾರಿದಮ್ ಇದೆ, ಇದನ್ನ ಕೇಳ್ಬೋದು. ಸೊ ಇದು ತುಂಬಾ ಸಿಂಪಲ್. ಓಕೆ, ಅಲ್ಗಾರಿದಮ್ ಅಂದ್ರೆ so these are set of instructions, okay, set of instructions for that particular problem. So the problem is like traversing one dimensional array alva, maximum element of the array. So illi kottidare example, let A be a linear array with LB and UB as lower bound and upper bound. LB lower bound andre first starting, upper bound andre end. So this algorithm traverses the array A by applying the operation process. Okay, operation andre adara hesaru ಒಂದು process anta to each element of A. A is the array name. So for location is equal to from lower bound to till upper bound, from start till end. Okay, so process is the function, okay, which is going to perform an operation. Process A, then comma location. So location start from 0, right? 0, 1, 2, 3 like that. So end of for loop. You all know about this primitive like for using the primitive data types we'll be using all these loops. Okay, for loop, and then write exit. So we'll be writing the instruction number also in the algorithm, remember it. So here is the program to input and output the elements of the array. Very simple one. So we always start with the header files. These are called header files. As you know, iostream.h, that means input output streams that you use for cout and cin won't be recognized if you don't give this. Okay, so this is a header file which has the function cout, cin, what it has to perform. So you don't have to write what is cout and all here. You can directly use these functions. That's why this is IO, input output manipulation. Then console input output conio.h means, okay, where you will be using this clr, scr, get ch, all those functions are defined in this. Then void main. So main is the function where the control starts. Here the execution starts from here. Okay, all the programs the execution starts where the main is there. So void means nothing. So this whatever the program or the function, main itself is a function, so it is not returning anything, that means void. So I'm not going to explain this every time. Remember this, first time I'm explaining. So you open the flower bracket. Okay, very important, wherever you open the flower bracket you close. So we also called something called indentation. So if you have one more function, you open a bracket over here and you end it over here, so that you will not like you don't have to go and search how many flower brackets, opening flower brackets are there, how many closing flower brackets are there. So for this, see exactly this line, then one more you open here, this one. So like when you are compiling, you may get errors, right, if you don't put the closing ones, or you put the closing one, don't put the opening one. So this indentation is very important. ಅಂದ್ರೆ ಒಂದು ರೀತಿಯ ನೀಟಾಗಿ ಬರ್ಕೊಂಡು ಹೋಗ್ಬೇಕು ಪ್ರೋಗ್ರಾಮ್, ನಿಮಗೆ ಗೊತ್ತಾಗುತ್ತೆ ಅವಾಗ ಎಲ್ಲಿ ಎರರ್ ಎಲ್ಲಾಗುತ್ತೆ ಅಂತ. ಸೊ ನೀಟಾಗಿ ಬರ್ಕೊಂಡು ಹೋಗ್ಬೇಕು. ನೋಡಿ, ಇನಿಷಿಯಲೈಸೇಷನ್ ಆದ್ಮೇಲೆ ಇಲ್ಲಿ ಒಂದು ಲೈನ್ ಬಿಟ್ಟಿದ್ದಾರೆ, ಈ ರೀತಿ ಎಲಿಮೆಂಟ್ಸ್ ತಗೊಂಡಿದ್ದಾದ್ಮೇಲೆ ಒಂದು ಲೈನ್ ಬಿಟ್ಟಿದ್ದಾರೆ, ಈ ರೀತಿ ಇಂಡೆಂಟೇಶನ್ ಅಂದ್ರೆ. ಓಕೆ, ನೌ ಲೆಟ್ ಸ್ಟಾರ್ಟ್ ಫ್ರಮ್ ಹಿಯರ್. int, okay, integer, it's a primitive data type, as you know. A of 10, so array of 10 elements, then one more variable called I, and one more for n. So n is number of elements. I will be used for the like this subscript value. Okay, so CLR SCR is a clear screen. So clear screen, what it does, previously if you have any output, it will just clear the screen. So you will have a like a clear screen where you are going to give the input and output will be shown. Otherwise previous programs output will be seen and followed by the like current program output. So clear screen we are using, and for clear screen it will go to this header file and it does the function. Okay, now see out, see out, see out. So whatever you have the output screen, right, on the output screen what you have to print, that will be from this function, see out, output screen. Okay, and these are all very important. Okay, double inverted commas are important, and this semicolon is also important. If you don't give this, it will give error. That's the syntax of this function. How many elements, that will come here in your output screen. How many elements? See in, this will not be printed. Okay, this will be taken as input. So how many elements, you give some number, okay, some 5. So that will be taken into the variable n. So C in, wherever you use, whatever the input you give, that will be stored in that particular variable. Next, C out, enter the elements. So what are those elements? Then you are going to enter, okay, some 1 2 3 4 5 6 7 8 something, whatever. So for how many elements you have put, okay, so we will be taking the input lesser than that, from 0 to that. Okay, say 5 elements means from 0 till like 0 1 2 3 4 5, that will be the subscript. So it should be less than 5. For I is equal to 0, I less than say 5, I plus plus. So this, you know, right, I plus plus means this is post increment. Okay, post increment, what it does here, when it does I plus plus, the value of I will be incremented. I is equal to I plus 1 is I plus plus. Okay, I is equal to I plus 1. You can write I is equal to I plus 1 instead of I plus plus. So this is same as I plus plus. Okay, so this will be, this is called post increment. So after this operation I value will increase. Okay, we'll be seeing this in the example also. So that's why it is taking much time for one single program, but it will be like helpful, and you will be very it will be very easy to understand other programs when we go to the other ones. See in A of I, so you are going to store whatever the data which you are inputting into A of I. So first A of 0, so A of 0, whatever number you put will be stored in A of 0. Next it will go again, because you have to loop till I is less than n. So you will go back here. I is still 0, right? But I plus plus has happened. Now I value is equal to I is equal to I plus 1, right? It will be 1 here now. 1 is still less than n. So it will go here. I plus plus will happen. Okay, but after this, so C in whatever EFI, the second element which you are going to put. So again, I value will become 2 because of I plus plus. So I is equal to 2, 2 is less than 1, yes. Then you are going to store again A of 2, whatever the number you input. Again it will go, I will become 3, and whatever the number you have put, it will be stored in A of 3. Again it will go, it will be 4, yes, 4 is still less than N, that is 5. So A of 4 is equal to whatever the number you have input. Again it will go I plus plus, right? I is equal to 5 now. Okay, 5 is 5 less than 5. No, 5 is equal, but we have not put that condition, so it will not execute this. It will come to the next line. See out the elements are. So here you are going to print the elements are, okay, for I is equal to 0, I less than n, I plus plus. So I is equal to 0. See out, this is width, how much you have to set. Okay, the space, set W. So A of I. So first it will be A of 0. Again it will go up. I plus plus will happen. A of 1 it will print whatever the numbers you have put. All those things you put. Then get CH means get char. Okay, get characters, whatever that inputting, and you are closing here. So here is the output. How many elements you will input? 5. Enter the elements. You have put all these elements. It will be stored in this uh, array called A. Okay. So A of 0 is 5, A of 1 is 10, A of 2 is 20, A of 3 is 15, A of 4 is 10. Next operation. Searching an element. Did you understand this program? If you have any doubts, you can write to me in the comment section. Okay. So next we'll be going to the searching an element. How do we search an element in an array? It refers to finding the location of the element in a linear array. There are many different algorithms, but the most common methods are linear search or binary search. There was a question about binary search for 5 marks. Okay, what was the question? Write an algorithm for binary search. Okay, from this particular lesson. So this is the highest marks fetching lesson. Remember, 14 marks from this particular lesson. Linear search. This is the simplest method in which the element to be searched is compared with each element of the array one by one from the beginning till end. So ಒಂದೊಂದು ಯಾವುದನ್ನ ಹುಡುಕ್ಬೇಕೋ ಅದನ್ನ ಒಂದೊಂದು ಎಲಿಮೆಂಟ್ಗೂ ಕಂಪೇರ್ ಮಾಡ್ಕೊಂಡು ಹೋಗ್ತಾ ಇರೋದು ಲೀನಿಯರ್ ಸರ್ಚ್ ಅಂದ್ರೆ. This is also called a sequential. ಯಾಕಂದ್ರೆ ಒಂದಾದ್ಮೇಲೆ ಒಂದು ಹೋಗ್ತೀವಲ್ಲ, sequential search. It is also called sequential search algorithm. Okay, A is the name of the array with n number of elements. ELE is the element to be searched, and this algorithm finds the location, okay, LOC, where this element ELE is stored. So okay, initially we put location is equal to -1 for P is equal to 0. Okay, P is a this index P is equal to 0 till n minus 1, till the end of the array. If A of P, first it will be 0, right, is equal to element. So this element is compared with each and every element of array. A of 0 they will compare. If it is not equal, go to 3. Okay, each and when it is equal, then location is equal to P. Then you should go to this step 3. If location is greater than 0, okay, greater than or equal to 0, then you have to print the location. Otherwise, search will be unsuccessful. So it will remain as -1 only. Okay. When we see the program, you will understand even better. Okay. As I explained in the earlier program about all these header files and also about this main. Okay. Now, these are all the variables which we are going to use in this program. A of 50 is an array of 50 elements. I POS ELEN. Okay, element which is to be searched under position and number of elements. Okay, we will do the clear screen function. See out, enter the number of elements. Okay, how many number of elements? You are going to create an array and then search. Okay, so you will see in the number of elements, then you will enter the number of elements. So you have seen all these things in the previous program, the same program. Okay, now you have the array. Now enter the search element. What are the items you have entered here. Now randomly you put something in the middle. Okay, then you will store that particular element to be searched in a variable called ele. Okay, element. Then as in the algorithm, for position you initialize it to -1. For I is equal to 0, I less than n, and I plus plus, okay, that now post increment. If ele, whatever the element to be searched, is equal to this double equal to, you have to put, don't put single equal to, then elv will be assigned to the ef0, the first element. Okay, that's not the correct. This is called, okay, logical operation. If this particular element is equal to this, okay, you are not assigning. See, if you put single equal, it will be assignment, then your program will go wrong, remember. Okay, then when it becomes equal, if it doesn't become equal, again it will go to the for loop and it will keep going till the end of the array. When this will become equal to this, then position equal to this particular index I, then break this loop, if loop. If position is greater than or equal to 0, then the present whatever this element is, so if you don't put double inverted comma and you write the variable, then variable value will be printed in the output screen. Okay, so what is the position you have to put, or else this particular element is not present. End L is the end of the line. Okay, it will start from a new line. You say don't put end L here, then just after this, if you don't have else, I have some other cout statement, then it will be continued here only. Instead of the new line, it will start from here only. So you will be entering the number of elements as 5 and you will create the array. Search element is 40. Okay, so 40, 1, 2, 3, 4th, right? So initially, for I is equal to 0, I less than n, I plus plus. If element equal to a of I is 40 equal to a of 0, it will search. No, again I plus plus, it will go. So I plus plus is a of 1. A of 1 is 20. Is 20 equal to 40? No. Again it will go back. A of 0, 1, 2. A of 2 is 50. A of 2 is compared with this element 40. 50 is equal to 40. No, it is not equal. So again it will go. So A of 3. Okay, A of 3. Is it equal to this search element 40? Yes. So what is the subscript? 3. A of 3, right? A of 3. So we are going to take this 3 and we will store it in this particular variable. Position is equal to this I is equal to 3, and it will break and see 40, ELE is the 40, E is present at position, whatever position we have stored, right, this number 3 at this particular number. Okay, so this is the program. So you have to be very careful with these programs. So if you have any doubt, you can write in the comment section. In the next video, we'll be seeing this binary search. Let's take more time in these programs so that you will understand. Okay, so next video, we'll be seeing the binary search. Till then, have a great time. Thank you.